Okay, so in this lesson, we're going to be talking about concavity again, right? And so looking at a picture of a polynomial, we're going to identify again where we're concave up and concave down, okay? So a function f is concave up. Sorry, trying to find the page. Maybe let you find it first. I love my abbreviations. Concave up. If the graph looks like a U or part of a smile. So we know this. A lot of reviewing what we're doing today. There's really only one new thing today. So concave up would be towards infinity, or negative infinity, I should say, to the left. And then it changes somewhere over here, okay? And we'll talk about that spot here in a second, all right? We are concave down on an open interval if the graph looks like an upside down U or part of a frown. So somewhere around here we change concavity, and then this is concave down, okay? So we have one interval of concave up, one interval of concave down. Where the concavity changes, that one point right there is called a point of inflection, okay? A point of inflection is where concavity changes. And if you remember back to our second quiz, the 1-1 to 1-2 quiz, you had to like name the interval where you were concave up and name the interval where you were concave down on a graph like this. And remember, I gave you guys a little wiggle room as to where or what that x value was, because it's very hard to tell visually where exactly the concavity changes, right? We know roughly it's in that area, but what is the exact point? The truth is, you can't find that point of inflection, which is what that is called. You can't find it without having calculus. You need to do something called a second derivative, which we don't do. So you can't find the actual point of inflection. But in our course, we do an estimation of that point, and that's the midpoint between these two. That's where this formula came in. This is your midpoint formula from a long time ago, like geometry. When you find the midpoint between 2 points, we estimate the midpoint as the point of inflection, okay? So we're going to estimate this point by finding the midpoint between these 2 points. That is our point of inflection. Okay, so we're going to call that point C because it told us to. Fine, we'll do it, no big deal. And then I'm just going to write these points over here. It doesn't matter which point you put first and which point you put second. Okay, just write the 2 points down, and then just find the average. Add together, divide by 2 of your x's, and then do the same thing for your y's. So I'm doing -2 plus 3 divided by 2 gives me 1/2, or 0.5. You could do 0.5 as well. And then on my y's, add the 2 y values together and divide by 2. And I get a point of 1/2, or 0.5, -1. And that makes sense. To the right 1/2, down 1 looks approximately where I am, but it's an estimate. It's not necessarily the exact point where concavity changes. It's an estimation tool we use for this level of calculus, pre-calculus. Okay, so pretty simple. Anybody have a question about midpoint? No? Okay, so let's make a connection between turning points in your points of inflection, okay? So if you look at this graph, we had 2 turning points, right? We turned here and we turned here. Turning points are where we change from decreasing to increasing or increasing to decreasing. 2 turning points, we had 1 point of inflection on this graph. Look down here. We have 3 turning points. There's turning point 1, turning point 2, turning point 3, 3 turning points. Think about your concavity. I'm concave up from here to somewhere in here. And I'm concave up from somewhere here to here. Again, we don't know exactly where it is. We're kind of estimating that's where concavity changes. Okay? And then we're concave down here. So we have 3 turns. How many POIs do we have? Just yell it out. How many POIs? 2. So we have 3 turning points, 2 POIs. Let's take it a step further from what we learned yesterday. Anybody remember what the degree would be if we have 3 turning points? 4. Go the other way. So remember I told you the degree tells you a whole lot of things? The degree, we'll learn even more in 1.5 about the degree, but the degree tells us if we subtract 1, there's 3 turning points. If you subtract another one, you have the number of POIs. Okay? So that is roughly true. There are exceptions to the rule, but in general, you can subtract 1 from the degree and get the turning point, subtract 1 from turning point to get the number of POIs. Okay? All right, so what we've been doing for the almost 4 weeks that we've been hanging out in this classroom is evaluating graphs, looking at graphs and pulling stuff off of it. Think about all the stuff we've been doing. We've done increasing and decreasing on the graph, increasing and decreasing with the rate of change, intervals of concavity, intervals of positive, intervals of negative, intervals of increasing, decreasing, domain, range, min, max, absolute. I mean, there's so many things. Now I'm throwing in points of inflection, all that stuff. There's so many things. So a lot of what we do is reviewing that. We have some new stuff. Yesterday we learned about min and max, and just now we learned about POIs. We're going to add that to all the other stuff we've been learning, okay? So we're going to fill this in together. This and our last example we have to do are great, excellent, wonderful reviews of pretty much what we've been doing this year so far, okay? So let's look at what they gave us. They gave us a graph, okay? And they gave us a table of values of certain points on the graph. This part is optional, but I highly recommend labeling your graph with these points. So let's break it down. There's 1, 2, 3 x-intercepts. Remember, x-intercepts is where y is 0. So I know I'm going to label these 3. Just trust me, it makes your job coming up here in a minute so much easier if you have these points written on here. So those are the 3 x-intercepts given to me. We have negative 4, 4 as a point. That's this guy. Negative 4, negative 4. And then we have this point. Glad they gave it to us because it's yucky. 0.9, negative 8.1. Okay? So all I did was kind of do a little pre-work. It's going to make the rest of this a lot easier. Okay? So let's start going through. And I don't remember if I said it yesterday. I know I said it 6th and 7th. 5th was a little foggy to me yesterday. I don't remember if I said it. But I don't like to call on people. Did I talk about calling on people yesterday? I don't like to just call on people like, Freddie, what's the answer to this? Because as a student myself, I used to hate that. I loved sitting in the front by choice. I loved school. I learned. I was goody-goody, you know. I loved what I was doing. But I didn't want to be called on, even if I knew the answer. I was just shy, okay? So as I'm getting to know you guys, I don't like calling anybody out. As I get to know you, I start to get a feel for who is willing to talk and that kind of thing. But I don't like to call anybody out because I don't want to embarrass anybody. So when I'm just asking, like, what's the domain? Like, I mean, just feel free to just kind of say it, okay? So anyway, what's the domain? Anybody? All real numbers. How do we write it in interval notation? Negative infinity to infinity. I'm not saying that all real numbers doesn't have a place in this class, but we typically use interval notation, okay? And so negative infinity to infinity, and we always, never an exception to that rule, always put parentheses around our infinity symbols, okay? How about the range? That's a little bit harder. Close. Negative 8.1, what'd you say for the rest of it? To infinity. Okay, here's something really weird, because not weird, but I'm hammering into your brains nonstop. Grab the x values. We use the x values, but that's only when it says interval. The range is the y values. The lowest y value we use is negative 8.1, and then it goes up forever. Good, Kaylin? Now, I know I have to put parentheses around my infinity symbol. What's going to go around the negative 8.1? It will be a bracket. That is not negotiable, okay? When we get to increasing and decreasing and concavity and stuff, I'll review with you what is required, like what's accepted. But this is true interval notation. Negative 8.1 is a point on the graph. We actually use negative 8.1 as one of our y values. So we would put a bracket on it. Let me ask you this. Can I change the order of these two numbers? Never. Ever, ever, ever. I've heard of other math teachers saying it doesn't matter what order. It 100% does, okay? Don't know where that information came from, but it is required to put your numbers least to greatest. Guys, it's just like saying, would you ever read a paragraph backwards? None of you looked at these directions and said, below table the in shown. No, we read left to right words. We read a graph left to right. We do interval notation left to right. Okay, it's very, very important. So always least to greatest, left to right, like a number line. Okay, now we're getting into intervals. Now that's just the x's. And when we're talking about where g of x increases and decreases, you can use parentheses or brackets. There's no rule, okay, except for infinity symbols are always parentheses. So looking at my graph, increase, where the graph goes up, it increases. So where it's rising. So this, if you just follow my pen, decreasing, then we're increasing, then we're decreasing, then we're increasing. So we have two intervals of increasing. Negative 4 to negative 2. Notice how Kaylin grabbed the x values. Thank you very much. Choose brackets or parentheses. Neither one is wrong. Okay. And then what's the other one? To what? Infinity, yeah. Okay, that's where we're increasing. Let's do decreasing. Be careful on this one because I know you guys would agree with me that this is decreasing right here, and this is decreasing. How do we name this? What's the first thing I'm going to write? Negative infinity. Common mistake there would be positive because it's pointing up. It is going up, but we are not naming what it does up and down. We're naming what happens left to right. So even though sometimes in these curvy graphs, it looks like it's going straight up, never is it, okay? So even if you can't see the slight like tilting out like this, it is happening, okay? So it is tilting to your left, which is towards negative infinity. Where does it stop decreasing? Negative 4, right, Daniel? And then we decrease again, starting at negative 2 to 0. Yeah. See how it's helpful to have the points written on the graph? It makes it so much easier instead of having to pop your brain over here, over back and forth. Okay? All right, the next 4 are what we learned yesterday. So if anybody was absent yesterday, there were like 3 of you, make sure if you haven't yet that you take the time to go through the video, at least parts of it, or look at the notes, something. Make sure you catch up to everybody. So if you are a turning point, you are a min or a max. If you're a turning point, you are a relative min or a max. So any turning point we have is going to go into these 2 boxes, one of these 2 boxes, okay? And we have 3 turning points, right? Here's a turning point, there's a turning point, there's a turning point. Turning points are your mins and maxes, your locals. So for maximum, that would be, this one, the negative 2, 0, right? So we would say that is 0 at, or use the at symbol. Yeah, and I'm going to put x equals -2. If I didn't do that yesterday, I probably should have. It looks better. I really could say either, but I like that better. And then we have 2 relative minimums. -4 at x is -4, and -8.1 at x equals 0.9. Weird ways of writing ordered pairs, right? That's all that is. So all 3 turning points got assigned either a relative minimum or a relative maximum. Now, are any of them absolute, meaning the highest or the lowest? Kaylin, what did you say? Yeah, is an absolute what? Yes, this guy is our lowest. Good job. This point is our lowest point. There's no other point, even with arrows in this graph, there's no other point that's going to go lower than that. Do we have an absolute maximum? No, because arrows going up are saying we have points going up, high, max, forever. So we pass this point already, just in our viewing area. So we have no absolute max, but we do have an absolute min, which is -8.1 at x equals 0.9. You can be in both categories, okay? You can be a relative min and a absolute min. You can, okay? We have 3 turning points. How many POIs do we have? 2. That's it. We just learned it, right? 2 POIs, because, how do we know it? There are, let me say this differently. Let me be a professional math teacher for a minute. 2 POIs because g of x has 3 turning points. What do I mean by being a professional math teacher? As we get closer and closer to the exam, which is not right now, okay? And as we prepare for each test with my test reviews, I'm always very, 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 very clear to you of what's expected, okay? So you will try, a week from now when we are taking our test on Thursday next week, you will finally trust me, I think, that what I say I mean, and that is you will feel very prepared for the test by doing my review. I'm very clear, okay? When it comes time for the AP exam, I already know what the FRQs are going to be. I know the questions. I already have them. I'm going to give them to you over and over again. In the last month to 6 weeks of this class before the AP exam, that's all we do is practice and practice and practice until you guys hate me, but you will all do really well in the AP exam. So when I'm talking about being a professional math teacher, I'm going to start now trying to use the best language when we write so that, because I can get lazy too. Like I have that. I do this 6 times a day, every day, you know, so I get a little tired. So, but I want to create good habits in you, just like with myself. And that is, instead of calling things it or the graph, it has a name. Call it by its name. I don't call you boy and girl. I call you Jennifer and Sam or whatever, okay? So 2 POIs because g of x, and they'll always tell you the name of the graph, okay? And you could call it g of x or g. So 2 POIs because g of x has 3 turning points, okay? So just the best way to write it. If you get in a good habit now, it'll be great later. Okay, last 2 of these, interval where g of x is concave up and concave down. Now, I see 2 concave up intervals. Watch my pen. Concave up, concave up. But where does it stop being concave up? That's that point of inflection. So I know it's concave up somewhere around here is where it stops, right? Same thing over here. I'm concave up, well, here I'm concave down. Let me put that in there. I'm concave down in here until where? I don't know, around this point, somewhere in that area. And then I switch to concave up again. So to find those 2 points known as your POIs, we're going to use an estimation technique called midpoint. So let's just take a quick second. I'm going to use this space right here and find those 2 points. So I'm first doing this point and this point. I'm just going to do the midpoint of them and get that, okay? So -2 plus -4 divided by 2 gives me -3. Add my y's together, divide by 2. So this point right here, my graph is getting very crowded, is -3, -2. We're estimating where concavity changes, known as a point of inflection. Okay, let's do the other 2 points. I'm going to circle them because now my graph is getting really messy. I'm doing this point and this point. That'll give me this right here. So I'm going to find the midpoint between these two. And I see some decimals and negatives and positives in here. So just so you know, I put this in my calculator and got my answers. I'm just not picking up my calculator again. I'm going to just steal the answer off of here. I get -0.55 and -4.05. Yuck, but whatever, right? We use a calculator, we get those ordered pairs. So this point all right. Finally, how do we name our interval of concavity? So concave up, we have 2 of them. We must use parentheses for concavity. That's the rule. So you don't get to choose. Again, that's why I choose to use parentheses on those other ones where it doesn't matter. That just keeps me in the mode of parentheses. But anyway, so I'm concave up. So that's -infinity, right? All the way up to the x value of this point, which is -3. Also concave up from this x value, which is -0.55, to infinity. Okay. Last one of these, concave down, right there in the middle. This x value to this x value, right? Practice, 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 practice. Lots and lots of repeating. In our last example, we're going to just do a little bit more reviewing and then I will set you free. Almost done. Stay with me. And if I went too fast, you have any questions, I'll be done talking in a minute. Just call me over so I can one-on-one with you. Okay? Good? All right. Sorry. Are you trying to see up here or down here? On the last page, there's 4 parts, and they really want us to be writing in math language. I'm not going to make us do all 4. We're going to write A in nice math language to help practice that, and then we'll just answer B, C, and D real quick, okay? So this is just more review. We have a polynomial. There's his name, P or P of X. Look at the first question. Is the rate of change of this graph increasing or decreasing at point A? And how do we know? Raise your hand if you think it's increasing. Okay, decreasing, must be everybody else. Okay, it's decreasing. Remember, rate of change, decreasing if you're on an interval of concave down. Remember, the concave down means your rates of change are decreasing. Good, for those of you that said increasing. At point A, the rate of change of P of X, see how I'm naming everything, is decreasing. You can spell things wrong. We don't care. I don't care if you put a comma in the wrong place, an apostrophe in the wrong place. Get your point across. Okay. What is the rate of change at point B? Well, here's point B, and I told you once upon a time that you can't find the rate of change at a single point without calculus. We can find an average rate of change between 2 points, but at one point, like we didn't find the slope here, we just know that it's decreasing. We don't know what the exact answer is, okay? Here, sure, go ahead. Go ahead. Okay, but there's an exception to that rule, guys. The slope at all your points, your turning points, are 0. Those are horizontal lines there. If you had to find a slope on a curve, you could at a turning point. And that line that is tangent to that point is horizontal. Do you guys think point C could be a point of inflection? Yeah. I'm just going to say yes, and we'll just talk about why. Well, it's between 2 turning points, right? That's where concavity visually looks like it changes. That's a great spot for a POI. Okay? And the last one is, listen to this one, is the rate of change at point D, is the rate of change at point D not increasing or decreasing, is it positive or negative? Positive. Why? The graph is increasing, right? Positive slope here, positive slope here, negative slopes here, positive slopes. So much to have to know on these graphs, okay? So I didn't make us write it all out, but we talked about it. But this is kind of like what an FRQ could look like, where you answer the question and give some reasoning that makes sense. Not just yes, no, whatever, okay? All right. That's not all that says A11. A11. And I keep kind of skipping over when it says closed or open interval. Finally, I'm going to tell you. Open intervals, when there's arrows on the ends, like most of our graphs, that's open. It keeps going. Open. Okay? 19 and 20 are closed. See if you can tell. I'll get it in a second. See if you guys can tell why 19 and 20 are considered closed. They have endpoints, dots. Yeah, there is not an arrow. It stops. It's closed. It doesn't keep going. When you don't have arrows on both sides, that's what that means. So look how we have an absolute max, where we would normally see an arrow. It's okay, though. It's a point. Okay, give me 1 sec, and I will come help y'all. that little clipboard right there.